Hello, everyone. Welcome to this session. My name is Faraz. I'm one of the co-organizers here at MLOps. Just before we begin, if you have any questions, please feel free to ask them in the chat with the queue in front so that we can collect and we can address them in the end. Also, please do visit our partners in the booth section on the left-hand side. They have some very exciting giveaways for the summit. So it's my absolute pleasure to introduce Mike. Mike is the front office data scientist and product leader with expertise driving business value utilization technology, programming, and machine learning. He has spent more than a decade in financial services and is currently a director in Global Equities at the Bank of America. Mike is also the professor at NYU, where he teaches machine learning in finance course, with an emphasis on practical implementation. He has also received a PhD in applied physics from Columbia University, where he pioneered cutting research on electron transport in low-dimensional material, and he's received more than 2K citations. So welcome, Mike, and over to you.
Thank you for all those kind words, even though I think I wrote that. So I guess I don't need an introduction because Faraz gave one. To myself, but just as he said, I deal with data science and machine learning as part of my full-time job. It's also part of my hobbies. I'm pretty passionate about it. I also teach it at NYU. And this presentation is really about some of the lessons I've learned at Bank of America and how it relates to MLOps. I think, historically, I tend to be more of the quant data science type. And then the last 3-4 years, I became really a user of machine learning models. And it's been about the last year where I've gotten really into the engineering components and began to really appreciate what MLOps is as a discipline and how it's necessary. And where it becomes necessary is sort of building the bridge between ideation to development all the way to use. And then in my own experience from conversations with colleagues outside of my current work and inside my current work as well, I see a big problem is AI adoption. And I'll get into what I specifically mean by that. But first, I'm going to start with a claim here. So my claim is, you can actually agree with this, but you can also disagree and still take something away from this talk, I hope. But the claim is based on my own experience, right? I deal with traders. Technically, my role is a trader, and I've built machine learning models for salespeople as well. But the claim is that convincing skeptical users to adopt an AI model, it requires a wide array, answers to a wide array of questions, right? That's multifaceted in that first bullet over there. And the questions are constant, right? They come at you very often when a model is live. And it's very important to have answers that are both quick, that sort of answer the question quickly and accurately. If you don't have those two elements of your answers, you'll lose trust right away. And we'll get into kind of that stalls the adoption process. Then when you think about, okay, who's capable of answering these questions, I think the field has evolved from go ask the quant or the data science who developed it to answer all these questions, to go ask tech. Maybe they have some of the answers. But now I believe it's mostly MLOps, right? That's kind of the description of who's in the position to answer the bombardment of these questions. And hence, I feel like MLOps is most essential to the adoption process. And so the cartoon at the lower left is from XKCD. And the reason why I find XKCD so funny, and everyone does, I think, is that they're an exaggeration of the truth. And so you have this data scientist on the top of a pile of, I guess, this linear algebra, and someone's asking them, how do you know it works? Or how do you know it's not wrong? And they just said, well, you keep stirring the pile until you get something that looks right. And, that's sort of tongue in cheek. But in reality, I actually see those types of answers to the questions. I think some of it comes about from the sort of simple APIs that machine learning gives, right? You feel like you could just throw in a bunch of data and you magically get these results out, right? This mythos of AI has led to that type of mentality that I don't need to understand anything. I just stir it, and I just watch how my F1 grows, and all is well. But those conversations between that person on the left and the person on the pile, which represents basically the end user and the developer, they're really facilitated by what I call like these 5 techniques of interpretability, right? And I'm going to go into each of these techniques individually, but they're trust, transparency, explainability, transferability, and informativeness. And that's what's at the bottom of the slide, but we're going to go into each individually. I want to do some definitions up front, which is, what do I mean? What do I mean by adoption, right? And for me, it's the period between specifying and building a product and the actual use of a product, right? If you talk about AI adoption in a wider sense, I have Google, McKinsey, Gartner, they all do wonderful papers about cultural absorption of AI. People do surveys like, how many machine learning models do you have live? And notice the terminology in those surveys. How many machine learning models do you have live? I think if all of you are in large organizations, live doesn't necessarily mean used, right? There's also organizational constraints and questions around how do you build the appropriate teams, right? And adoption is all of those. But for this, it's going to be the people in that cartoon who just built a pyramid and that are staring at it and saying, okay, why did we build this? What exactly do you want me to use here, and how? And so, it seems absurd, but it actually happens all the time. And I have some reasons at the bottom about why that actually happens, right? So how do you arrive in a situation where you built this thing and then the end users kind of give you resistance? And there's sort of 2 main themes here, and probably they fall in one of the 2 buckets. Maybe there's a third. Enterprise initiative / senior management demands, right? They get these great ideas. Either it's on purpose sometimes it's not. But they say, hey, we want to move this organization. We're simply going to build this and they will come, right? Sort of that baseball phrase, right? If they build it, they will come. And it's on sort of the developer. They end up getting blamed, the data scientist, if it's not ultimately not used. They're going to say, why'd you build that piece of junk? No one uses it. And in fact, it takes an array of skills to make things adaptable to a user. The second reason why something might be built and not necessarily used is having product management involvement and project management involvement. Those are 2 different things, is very clear. And people can, give entire lectures. I'm sure, someone's giving a talk on that in this conference. But, having clear product specification, communication throughout, as opposed to, hey, go build me this, come back 3 months later, and here it is, right? And to get from that gap of building something and actually using it, I believe that's where interpretability comes in, right? And so Lipton has this great paper. This talk has all the links in it, but you should probably take a look at that paper if you're interested in the topic of interpretability. But he says that he defines the demand for interpretability as a mismatch between formal objectives and the real world costs in a deployment setting. So formal objectives are like the F1, right? That's what we as data scientists sit down and try to maximize. But in the real world, they might be asking different questions. That doesn't necessarily mean you did anything wrong, right? Sometimes you actually have to translate the business question to an effective objective function you can actually work with, but you can't feasibly handle all the constraints that are implicit to the business, right? And so that's why interpretability, it bridges that gap, right? There's always going to be a gap between the data science objective function and the business one, and interpretability bridges that. And I found a nice definition of MLOps down here. We won't get into that since your whole conference is about that, but it's essentially, I think of it as a discipline and not a single technical solution. And that's why I think they come in on interpretability. So specifically, where do they fit in, right? What are the resistance points to adoption, and how does interpretability come in? The 5 common resistance points that I see, the interpretability theme that's associated with it, and how we solve it. And you'll see how MLOps organically integrates into that. So the first resistance point is, I mean, this is hands down, the model is going to be wrong, right? And so they don't trust it. And we'll do a slide on, how do you overcome trust, right? What does it mean? And then how do you overcome it? The model's a black box, right? So the end users feel uncomfortable because they have no feel for it, right? Like their intuition, right? For that they claim to have a feel for it, but the model sort of takes their hands off the control. And the interpretability theme there is being able to give transparency. Here, I think MLOps probably has the least amount of input, but they still have some, as we'll see. Another complaint, number 3, is that the data scientist, the end user has no feel for the output. And this is what I think I commonly thought of as interpretability, but it's called post hoc explainability. That's sort of like your feature importance, that kind of thing. And we'll kind of describe what that actually means in a real world setting. Number 4, a resistance point, they'll claim that the model only works in a dev environment and not in a production environment, or that the business has actually changed, right? In finance, a very common thing is non-stationarity, right? This time is truly different kind of thing. And there's actually a valid concern around that. And so transferability becomes an important interpretability theme that we'll need to hurdle. Number 5, and this is the one that's not always said explicitly, but you feel an undercurrent of it if you do enough of it. And that is the end users have this inherent fear that the model will replace what they bring to the table, right? Make them redundant. And here, the job of interpretability is informativeness. How can we make them better? How can we use the machine learning model to show them ways to get better at their job, right? Move the dumb cases or the modelable cases to the side and work on the things that are much more difficult. And so let's go into each of these 5. I think I've got 15 minutes, or let's say I got about 10 minutes. So I'm doing the calculation. I'll try to do 2 minutes per slide, right? And some of them are more interesting than others. So the first interpretability theme we have is trust. What do we mean by trust? Well, it means different things to different people, right? So for a data scientist, performing well means having an objective function score, your R squared, your F1, et cetera. And that's your North Star. A software engineer cares, they trust it if it's deployed well. A data team trusts it if it's governed well, right? The end user sort of has more qualitative trust metrics, like they want to understand the model. Management, they ultimately just care about the bottom line. They wanted to achieve results. And so, this always goes back to this idea of why is a machine learning model different than a classical model? And really, Fowler and Andrew Ng, this pyramid on the right is from Fowler, describe that ML is data plus code plus model, right? There's 3 things you have to do to verify trust, as opposed to traditional software, which might just be code. And so really it's all about testing, right? You have to test all of these corners and then some. And one big thing, is this idea of continuous deployment, continuous integration. And I think I've seen very few large organizations capture this idea of continuous integration very well, right? We're mostly in the waterfall development phase, most of us, right? And there you see the different touch points or development cycle, let's see, AI model lifecycle components at the bottom there. And they're each kind of have one-time interaction points among all the stakeholders, right? In development, usually the quant is sitting by themselves. They may go a few times to the end user to show their results. To prove to themselves, testing, the data governance team, the technology team, and the quant team, they might be all doing those different tests. But it's really the monitoring where becomes a key point for this continuous touch points, right? And what I see is a model gets deployed into production, and then people begin to care, right? It becomes theoretical until after deployment, right? Where that orange monitoring chevron is. And that's when the real questions come in, and they come fast, they come difficult, and they come in a variety of things. And that's why having a proper monitoring system is so important. And we'll talk about a little bit more about monitoring in, I think, in transferability, because you'll see why it's even more important. Transparency, I'll touch on very quickly because I think it has the least applicability to MLOps. But there's really, three kind of subcomponents of transparency as Lipton defines it: simulatability, composability, and algorithmic transparency. And inside that simulatability, you could think of it as, can a person contemplate the entire model at once? And most typically, the answer is no, right? If beyond a few calculations, simulatability is very hard to achieve to gain some low-level mechanistic understanding. So you kind of can put that to the corner. We're never going to be able to achieve that given our level of sophistication in ML. And then even if you go to linear regression or something like that, it becomes difficult. Composability, this is a big topic that I kind of talk about in a separate talk, where it's important, I think from a junior data scientist perspective, I see a lot of people trying to do a whole shebang model, right? Where they sort of just take their end output and they try to model that as their target variable. And what I advocate for is having more of a composable model sequence. A classical example of that in finance is when you predict expected loss, you usually predict it in two components: your probability of default and your exposure at default, right? Or your loss given at default. And then you multiply the two or three components. And, from a method that might be abstract if you're not from finance, but there's several other examples. But mathematically, what you should be able to do is say, can I decompose my calculation, my target variable, into multiple components? And, there's multiple benefits from that. But one of them is interpretability, because instead of trying to understand the end result, there's sort of this incremental component that individuals can investigate. And from an MLOps perspective, you could see the challenge. If your your ML pipeline becomes that much more complex, and you'll have to output results from the subcomponents. Algorithmic transparency, I think that's clear, right? So instead of going right to the neural network, start with something simple like a historical model. Then you move on to linear ensembles and deep learning. And there's different spectrums there one can draw on. And as you get more complex, algorithmic transparency goes down. From an MLOps perspective, what I advocate for is, as you go up that evolution chain, you should always have some historical, if it's not computationally costly, or maintenance costly, you should have some alternative models in play. So when things go wrong or you're uncertain about the results on the more complex models, you can always go back to your simpler models and do some diagnostics, right? So you can see from an MLOps perspective, having multiple models run simultaneously is the challenge. Let's get into post hoc interpretability. This is the one where you can do a couple of lectures on this topic. It's a great topic, and when you think of interpretability, I think this is where most of us sort of think of it. So LIME, you're probably all familiar with it. Very briefly, you want to explain one output, and what you do is you basically pick that output, you simulate some results around it, and you fit a glass box model. So what I mean is, a linear regression, a decision tree, etc. And it explains the model very locally. And, a decision tree, you could just look at it and see why it made that decision. And that's how LIME works, essentially, right? Shapley is something I use very actively. It's sort of this game theoretic way of attributing payouts among features. And, you could think of it, I think I wrote down a simple example to give you, but yeah. So if you think about like a return on a portfolio, let's say you're trying to predict a return on a portfolio, and I'm using another finance example, but it goes to even cancer outputs, which is what that graphic shows you below, which is from the link up there. You have these covariates, and they're all sort of explaining your prediction. And what's nice about Shapley is there's some baseline prediction, right? You just think, okay, on average, the market goes up 1% per year. I'm just using fake numbers. And what Shapley does is say, on that 1%, your covariates that you use to make the prediction attribute a certain amount plus and minus that value. So as an example, volatility might be bad as an example, right? Fake example. And hence, from that 1% baseline, it might go down 2%. And now your return is negative 2%. And another covariate might be, GDP output for the year. And that has a positive output. So that has a plus 5%. And so you go from 1% down to negative 1%, plus 5% to 4%, right? And so Shapley has these very nice additive explanations that allow you to quickly look at it, right? And in that graphic there, I think they're predicting something like probability of having a cancer. And there's different kind of covariates that explain it that make it more likely you have it rather than less likely. I'll stop there on Shapley because that's a big topic. But if you don't know about it, you should investigate it. Lower left-hand corner, I think, we think of feature importances as very popular. I think by now we know kind of we have to be careful. And so, if you haven't already, you should read that paper I have at that lower left there, Beware Default Random Forest Importances. So note that they say beware. They don't say don't use it, but you should understand the assumptions that not only go into feature importance, but permutation importance, Lime and Shapley, et cetera. Because when you're building a story on your interpretation, there's always assumptions that come into these, right? And so from an MLOps perspective, it's actually extremely mandatory that if you're outputting 500,000 predictions per day, as we do here on the floor, you have to have explanations for each one of those, right? Now your dimensionality grows, the computational cost grows, and you have to think about, okay, when do they need the explanations? Because maybe I have some latency issues that I want to do this attribution later, et cetera, right? Transferability. So I think of this as sort of out of sample, right? So we've developed it in a lab. And, I'm just going to, after this slide, I'm going to stop because I think I'm up against that 5 minute. But I think of this as the out of sample results. So you've developed a model in the lab and now you've deployed it to production, right? Do you expect everything to work the same? No human does, right? However, I see over and over again, folks not do the proper due diligence to ensure that things have not changed, right? And so there's different things you can check. Data integrity or data drift, that's a shift in your covariates or your X's. Performance shifts, also known as concept drift, right? How, over time you'd expect, COVID hit. So your e-commerce models have shifted and you should see these maybe step functions or slow degradation in your model, right? And you might need to refresh and retrain these. And there's a whole bunch of other metrics you'd want to monitor if you kind of really care about your model. And if you don't, someone else, the end user, is going to care and they're going to ask you questions. And if you don't have these structures in place, ultimately, you're going to be inundated with requests and, adoption ultimately might fail. And so I'll skip informativeness. There's a clever thing called Twyman's law, which you should take a look at, and also kind of dissection of where the model is actually right is important. And so kind of I'll leave you with the takeaways, which is, I'm a firm believer that adoption is generally facilitated by having good model interpretability, and that has to be timely and accurate. And the MLOps discipline is the place most suitable, as you saw in all of those interpretability slides, to provide the tools necessary, both for all stakeholders to get a view of what's going on in the model. So I'm going to stop there, Faraz, and I think 1241 is where my limit was. So
this is great. Thank you so much, Mike, for a very fantastic presentation. It looks like the questions are just coming in, but maybe I can ask that. What would you say is kind of the most important technique, I guess, and kind of how would you kind of use that to help? with the adoption?
I think from my perspective, what I've seen, and this is just based on my own experience, and I think I emphasized it when I was going through the slide, it's monitoring, right? You can never do too much monitoring. People have an unlimited imagination for questions, and hence, you think you're measuring everything, and what you'll find is, your monitoring scope may or may not cover it, right? And when people have a question, they want it answered right away. If it's not answered in a timely way or a graphical way or a way they can digest, they sort of lose interest very quickly, and your window for adoption actually closes very quickly.
Absolutely, yeah. We have another question from Alexander, and he asks, how do you document interpretability with the workflow you just described? So in other words, how is the techniques integrated into your workflow or business process, assuming that you just don't email results?
I think, there's a couple of things. I mentioned dashboards in the monitoring, right? So having the ability, we kind of skipped over the tools component, Splunk, et cetera. There's no clear playbook here, right? There are some companies that are doing stuff around AI responsibly. And what they do is they demand these types of interpretable tools in order to stave off unintentional or intentional biases that occur in AI, right? And so they're the leading kind of literature I see on saying, hey, make sure these are being tracked and governed appropriately. But there's no sort of, it's usually generally occurs ad hoc where someone asks, okay, how many predictions did I have today? And then they ask it 5 days in a row and someone's like, okay, maybe I need to put a Tableau dashboard together, right? But there are already nice tools. There's sort of an evolving field and it changes every year, right? It changes very quickly. And I'm sure next year during this talk, you'll see some great monitoring tools. But ultimately, when those questions come in, they get tabulated. There's a list of common questions that I deal with, and I ensure that they are written to some location. And I mentioned earlier, latency is an issue, right? There's some calculations that need to be done for these monitoring. So you want to know when the end user is using it as opposed to when the compute time is being used for the actual predictions. Maybe there's some time to actually build in those dashboards as necessary. But it could be Tableau. I mean, I've seen that. It's not the greatest tool in the world. We're Bank of America, so we have sort of a larger resource pool. I've seen Splunk used very well. And those are a couple of tools, but there are many more.
Absolutely. Yes. So I guess it just comes down to understanding your end user and kind of working with that to kind of how you can make it easier for them to kind of visually see it as well too. So that makes a lot of sense. Yeah. We have another question. How do you balance model complexity with interpretability, especially in enterprise setting where most of the models do have a very strong IP? How do you manage that?
Well, I'm in finance, and we don't do a lot of. In my particular field, I'm on the equities floor. Right now, we're not using image recognition nor NLP. We have some NLP components, so I completely stay away from deep learning. Right, we're just not there yet, and the size of the data tends to be prohibitive towards that. You could ask different people; they have different opinions. I believe always starting on a historical model and building beyond that is the way to go. Generally, I've seen people try to go 0 to 1, having nothing to a machine learning model. There tends to be issues there because they're not even thinking quantitatively to start with. So starting with some historical average and demonstrating the weaknesses before you move on to your lasso and ridge before you move on to your random forest. I think that's the way I kind of preach it, but everyone does things differently.
Absolutely, yeah. Also, you made a really good point on kind of getting the business use case or strategy before kind of building implementation and adoption. How or where do you even begin having a conversation, or how do you facilitate the conversation between the technical team and the business team? Is there a framework that you see that's been implemented on your team?
Absolutely, yeah. I mean, this was an MLOps kind of audience, so I stayed away from that part of it. And I'm actually giving a talk next week at the bank about that very thing, right? because it is probably the most essential part of the process, and it's also the most underrated. But it's, how do you take that business problem, turn it into a quant problem, and then write the specifications around it in such a way that kind of it creates success. So I think, ideally you have someone like a product manager who's able to understand how to translate the business speak to the quant speak, right? Because it's not always one-to-one. Also, knowing your constraints, right? Like, I don't know the audience, but, I work in a large organization. There's always constraints, right? Like you can't use cloud services, just as a simple example, or it's not easy to use one here. And hence, taking a vendor product and bringing it on-prem and then thinking it's going to seamlessly integrate, a product person could appreciate that, the quant maybe not so much, the end user not so much. And so having a product specification, so just to answer your question, to give you concrete, number one, having a business use case, maybe a one-pager about what they're trying to achieve in pure business speak, and then converting that to a product specification. And that might be about 5 to 6 pages with end user stories, and then the next step is for the quant to sort of translate that into the model. It's a big topic, important one.
Yeah, absolutely. Like, I think like that itself is a talk by itself. Like, how do you get the teams to kind of agree on the business use case before itself? And obviously that naturally will help with the adoption and the trust, because if you do get a lot of stakeholders involved prior to the build, and that makes absolute sense for sure. Absolutely.
Cool. Yeah, absolutely. The gap between the pyramid and the people staring at the pyramid shrinks when you have that. And then, the MLOps, I believe, sits in that gap. The gap will always be there, but like you said, agree completely.
Yeah. And it also helps with kind of the end of the day, like when businesses are trying to figure out the ROI by putting these models in production and allocating resources for the teams and like whatnot, right? So like it kind of helps create that cycle of adoption with the team as well too. So.
Absolutely.
Yeah.
Yep.
Cool. I'm just going to ask the attendees if they have any more questions. So we'll give it a sec. All right. So it looks like that's all the questions we have. Thank you once again, Mike, for a fantastic presentation. It was definitely very useful for us in the MLOps world, but it's also great to see kind of on the business side as well too. So thank you so much.
Yep. Thank you everyone for your attention. Really appreciate it. Take care, everyone.
Thanks, everyone.